In this video, we want to solve for x given x times x times x minus x times x is equal to 48. So we have x times x times x minus x times x is equal to 48. Here, this will give us x raised to power 3 by indices. Then minus here, this will give us x raised to power 2 is equal to 48. Now, x raised to power 3 minus x raised to power 2 is equal to 48 can be expressed as 64 minus 16. So this is x raised to power 3 minus x raised to power 2 minus 64 plus 16 is equal to 0. 64 here is 4 raised to power 3 and 16 here is 4 raised to power 2. So we can express the whole equation as x raised to power 3 minus x raised to power 2 minus 4 raised to power 3 plus 4 raised to power 2 is equal to 0. Then I'll bring this closer to this. So we have x raised to power 3 minus 4 raised to power 3, then minus x raised to power 2 plus 4 raised to power 2 is equal to 0. We can also write this as x raised to power 3 minus 4 raised to power 3 minus x squared minus 4 squared is equal to 0. This right here is difference of 2 squares, while this is difference of 2 cubes. Let's factorize this. X raised to power 3 minus 4 raised to power 3 minus, this will give us x minus 4 times x plus 4 equal to 0. Then we can also factorize this by identity. A raised to power 3 minus b raised to power 3 will give us a minus b times a squared plus ab plus b squared. So it means this part becomes x minus 4 into x squared plus 4x plus 4 raised to power 2, now minus all of this, so minus x minus 4 x plus 4, and this is equal to 0. If you look at these two factorizations, there is x minus 4 here and also x minus 4 here. So we can factorize x minus 4 into brackets. What will be left here is x squared plus 4x plus 4 squared here is 16. Then what will be left here is this, so we have minus x plus 4 is equal to 0. Then we tidy all of this up. We have x minus 4 into, this is x squared plus 4x plus 16 minus x minus 4 is equal to 0. So we have x minus 4 into bracket x squared. 4x minus x here will give us 3x. Then 16 minus 4 here will give us 12 is equal to 0. Then everything is tidy. So this means that either x minus 4 is equal to 0, or this x squared plus 3x plus 12 is equal to 0. So from here, x is equal to 4. We call this x1. That's the first solution to this problem. Now let us go and solve this quadratic equation to get the other solutions. Let us compare this equation to the general quadratic equation. Ax squared plus bx plus c is equal to 0. From here you see a is equal to 1, b is 3, and c is 12. Then we use the general quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's substitute these values into this equation. This will give us a, or x rather, is equal to minus b, which is 3, plus or minus the square root of b squared, which is 3 squared, minus 4 times, then times c, which is 12. Then divided by 2 times a is 1. So x is equal to minus 3 plus or minus the square root of 3 squared is 9, minus 4 times 1 is 4, 4 times 12 is 48. Then divided by 2 times 1 is 2. So x is equal to minus 3 plus or minus the square root of 9 minus 48 here is minus 39, then divided by 2. So x is equal to minus 3 plus or minus, here this is something as saying square root of 39 times negative 1, square root of that, divided by 2. Then we have x is equal to minus 3 plus or minus, I'm going to separate this into square root of 39 times square root of negative 1, then divided by 2. So we have x is equal to minus 3 plus or minus, square root of 39 is still square root of 39, and then square root of minus 1 is I, then divided by 2. There's not much again that can be done to this except to separate this plus or minus. So we have two different values. This will now be our x2 is equal to minus 3 plus root 39 I over 2, and then the final value, which is x3, will be minus 3 minus root 39 I over 2. So those are the three values from this problem. And you notice that because of this I, the last two values are complex or imaginary roots or solutions. So we only have one real root. While these are also roots of the solution of the equation, we only have one real root, which is x is equal to 4. Now let us check to verify that this is correct. To check that this real solution is correct, we need to substitute its value into the given equation. X times x times x minus x times x is equal to 48. Now x is 4, so we say 4 times 4 times 4 minus 4 times 4 is equal to 48. 4 times 4 times 4 here is 64. Then minus 4 times 4 here is 16 is equal to 48. And of course, 64 minus 16 is 48. So 48 is equal to 48. The left-hand side balances the right-hand side. Therefore, this solution is correct and acceptable. Thanks for watching. Please like and share, and remember to subscribe to my channel, and I'll see you in my next video. Bye.